You may also hear about push and pull systems. These are nothing but fancy, easy to remember labels for our make-to-stock and make-to-order systems. The make-to-stock is the push system since all prior processes and workstations, including suppliers, tend to overproduce and push their outputs to the next process. Every process seems to be pushing inventory down the supply chain, producing according to its capacity, mindless of the takt time or take-up rate of the next process. Conversely, the make-to-order system is a pull system, since every station doesn't process or start processing unless pulled by demand or by the next process. Everybody's pulling everybody else down the line like a train. Let's now try to visualize our two production systems. Let's start with our original 5-station process with their capacities indicated here. Suppose demand is 10 units per hour. Let's see a make-to-order stock case in which everyone tries to produce according to their capacity. See what happens to their actual or throughput rates. This system, which we shall call make-to-capacity, will create costly work-in-process and finished goods inventory at the end of the line. A make-to-capacity system often assumes a seller's market, a build-it-and-they-will-come environment. A variation of the make-to-stock system, which is somehow better, is one in which everybody synchronizes with the bottleneck as shown here. At steady state, this make-to-bottleneck process will produce only finished goods stocks, but not work in process. Note that both systems will be producing more than the demand rate of 10. Let's now see how our process would behave on a make-to-order basis under the same conditions. There are two ways to actually meet the exact demand or orders. The first is what I call the push-pull process. Here, every process produces to capacity or plans based on forecasts, except the last process or processes which produce based on actual demand or takt time. There are no finished goods inventory as goods are immediately delivered or sold just in time. This can be considered a hybrid just-in-time system with just-in-time delivery but without just-in-time production, since work-in-process inventories are created in the upstream processes. Here the upstream stations are pushing with their capacities, but the downstream stations are being pulled by the market. Now, why would anyone want to do this complex production? For instance, you're making cars or something similar. Your upstream processes may be high-capacity machines, making low-variety standard parts like presses stamping uniform metal brackets. But your downstream processes are lower capacity, labor-intensive assembly processes that make high-variety car models. According to our previous slides, the first half of your factory would be better off making to stock, while the second half better off making to order. From the customer's point of view, however, this may seem like a pure make-to-order system, since he doesn't see nor care about what you do in your back office. Now let's consider a completely pull make-to-order system. Here, as you can see, everyone produces according to the demand rate of 10 or takt time, and not according to its capacity or the process bottleneck. Notice that there are no work-in-process nor finished goods inventory in this system. Let's take a look at a pull line or just-in-time line in detail. It is a special type of make-to-order system in which all workstations, not just the last one, strictly produce according to the takt time. Here, a workstation will only produce and deliver only if required or pulled by the next workstation, also referred to as its internal customer. Ideally, the parts or raw material supplier of a just-in-time process also delivers inputs according to takt time. The just-in-time line is also known as the one-piece flow, Lean system, or Kanban system. It is one-piece flow since there is only one piece or one small batch between each station at any time. Since it minimizes, if not eliminate, work-in-process and finished goods inventories, a just-in-time line is also a lean system if we consider all forms of inventories as waste and unnecessary. Why call it a Kanban system? The Japanese term Kanban means a signboard. In a just-in-time line, it refers to the physical or electronic signal a station sends to its prior station, which tells it to start producing or delivering the next unit. The Kanban is a sort of internal purchase order one receives from its internal customer. The Kanban effectively controls the process flow in a just-in-time line and ensures every station works according to TAC or the requirements of its next process. Any line, balanced or unbalanced, can be converted from a push to a pull or just-in-time line. One criticism or weakness of a just-in-time line, as you may have observed, is its low capacity utilization. More often than not, as it produces to demand, most if not all processes and stations will produce less than their capacities, including our former bottleneck station C. The way to get around this weakness is to redesign your process or create a new one such that the line is balanced and every station's cycle time matches the takt time. In other words, the throughput rate of each station is its capacity. Direct labor utilization will be 100%, and work in process and finished goods inventory are virtually eliminated. The balanced just-in-time line will be the least cost process configuration.